Okay, in this video we are going to discuss interpreting graphs of functions. So on this first part, you are asked which variable x or y do the notations f of x and g of x represent, and they're all going to represent y, the variable y. And if f of x and g of x are equal to each other, then their graphs intersect. If f of x is greater than g of x, then graphically f of x is above g of x. And then if f of x is less than g of x, then f of x is below g of x. So f of x and g of x can only be compared over the interval, so it's talking about down below here. F of x and g of x can only be compared if you're looking at your graph from -4 to 7, and that 7 is included because that is the interval where they both exist at the same time. Okay, so now looking at the graphs, and let's see, f of x is the dashed line and g of x is the solid line. So it wants us to use a marker or colored pencil to represent our three cases that we just talked about. So for the first one, it wants us to look at where g of x and f of x are equal. That's going to be where they intersect. So they are intersecting there at -2, and they will intersect again, it looks like way over here at +5. So that's the two places that they intersect. And then the next place, they want us to see, well, where is f of x greater than g of x? And again, f of x is the dashed line, so we're looking where the dashed line is above the solid line. So that's going to be way up here and way over here. So that's going to be from -4, again, remember we're going over the x values, so -4 included, or not included, to -2, and then union, and then this other side is 5 to 7, and 7 is included there. And now we're looking at our next problem, and that's going to be below where f of x is less than g of x. So where is the dotted line below the solid? And that's going to be through here. There's where it's below. So that's going to be from -2, and it's going to be parentheses, -2 all the way to 5. So there's great examples of where we're equal to, where we're intersecting, where we're above, and where we're below. All right, and so again, this is talking about, should we have just one open, or do we have just closed intervals? So what do we think? And we need to have both for this. And the reason why is because it just depends on what we're describing. And so here it really just depends on the functions. Just depends on what we're given. And we're going to identify the domain and range for each one. For f of x, the domain is going to be from -4 all the way to 7, bracket. And the domain for g of x is going to be from -5 to 7. And for the range, we're going to have from -2 all the way over to 6, and then from -4 to +4. All right, now looking at our next part, and again, keep note that f of x is the dashed line, g of x is the solid line. And so the first question it's asking is the values or value of x such that f of x equals 0. So f of x equals 0, that means here f of x equals 0, which means x-axis, you're looking for whenever the graph is on the x-axis. So again, f of x is the dashed, so it looks like you're going to have a point here, and it looks like this would keep on going and extending that on out. It looks like it could be, I know for sure 1, and maybe looks like a 15. Now looking at the values of x such that g of x equals 0. So again, g of x being 0, that means again, this means x-axis. So for what values are you sitting on the x-axis? So let's see, that looks like a -4.5. So x could be -4.5. Let's see, the next one looks like it's going to be 6. And on over, it looks like -10.5 for that one. Right? And then where in the world do we have values where f of x equals g of x? So that means this notation here, that means they intersect. Very important for us to know these things. It's where those are going to intersect, and so let's look at our graph and see where do those intersect. So that's going to be about, this first one, let's say about a fourth or 0.25. There, oh, it's negative. And then over on this other side, it looks like they're going to intersect at about 9. All right, let's look at some others. Oh, now, and this is going to be interval notation now for sure. We're going to look at where f of x is less than g of x. So let's make ourselves a note. That's going to be where f of x is below g of x. That's what that means. So f of x is below g of x. So that's going to be, let's see, it's always going to use some point of intersection for sure. And f of x is the dashed line. So use where they intersected. That's going to be an important part. So negative 0.25 all the way to 9. It's going to be where they're below. And then, of course, they're equal to each other at 9. So then pick up on the other side of 9. And it looks like, that one's going to go on to maybe 11-ish. Okay, for our next part, we have the values of x such that f of x is greater than g of x. So now this is going to be where we have f of x is above g of x. So again, we're going to have an interval here, and we're going to go above. So where are we going to have those values? Looks like we're going to start at negative 9 and go to negative 0.25. So negative 9 to negative 0.5. That's everywhere that f of x, the dashed line, is above the solid line. And then our next one, the values of x such that f of x is greater than 0 or above the x-axis. So here, that notation there, we're talking about above x-axis. So that's going to be from negative 9 to 1, and then from 15-ish on to infinity. Okay. Now let's look at some g of x values. So the values in which g of x is increasing. So the values over which g of x is increasing, that's going to be from negative 6 to 3 union. And keep in mind again, you're looking where the solid line is increasing, so that's why we're saying negative 6 all the way up through here to 3, you're increasing. And then a union, and then you're increasing again from 9 to 11. So that's where these numbers are coming from. And then areas where you're decreasing, that's going to be from 3 to 9. And then where g of x is constant, that's going to be from negative 11 to negative 6. Okay, moving on. Now let's look at where f of x is increasing and f of x is increasing over 3 to infinity. The value of x such that f of x is decreasing. F of x is decreasing from -9 to -6, union -1 to 3. And then where is our dashed line being constant? Well, that's going to be from -6 to -1. Okay, now let's look at our other values here. We're looking for where the value such that f of x is negative, so that is going to be where the graph is below the x-axis and is dashed. It's the dashed line below the x-axis. So that's going to be from 1 to 15. It's going to be all of this down through here, all of that. Okay, and then where the graph, where the, oh my, now we're multiplying them, where the product of f and g is less than 0. So that's where one's positive, one's negative, and we multiply those. So that's going to be where they're on the opposite sides. One's above, one's below. So where in the world do we have them opposites? Well, from -9, we can start there, to -4.5. Union. Where are they on opposite sides again? From 1 to, yeah, they changed there at 1. 1 to 6, they changed there. And looks like they change again over at 10.5, don't they? 10.5 to 11. There we go. That was a tricky question. So where their products are negative. So that's one's above, one's below. Not where they're both above or both below. That's going to be the next one. This one is going to be where they're both above or both below. That's going to be the same sign. So where is that going to happen? Well, that's going to be from -4.5. We need them both above or both below. So that's going to go to -4.5 to 1. And then union from 6 to 10.5. All right. All right, so for this one, we're going to have to write the equation for our 3 graphs that are given. So let's go ahead and get started with that. We see that our function's name is h at x. And so let's go ahead and sketch that out. And notice that our boundaries are from -6 to -3, and -6 is included. -3 is not. And from -6 to -3, we have a line. So what we're going to do with our line is get our 2 points and write the equation of the line. So our 2 points, let's take this included point down here. So that's going to be -6, I'm just going to write it up here, -6, -5. And another good point it looks like could be right here. Don't use this one up here, it's open circle. Alright, so right here's a good point. So it looks like that one's going to be -5, -3. So -5, -3. And so we're going to do our slope. Remember, slope is rise over run or changing wise. So it's going to be -3 minus -5 over -5 minus a -6. So let's see, in the numerator, that minus a negative is plus a positive. So that's going to give us 2. In the denominator, we're going to get 1. So our slope is 2. And then we're going to pick our point. Remember, y equals mx plus b. And so we know our m is 2. And we're going to pick, I don't know, I'll pick the bottom one. And that's our x and our y. And that'll find our b for us. So y is -3 equals 2 times -5 plus b. So that's going to give us 10, -10, add that over, so that's going to give us 7 as b. So we have our equation of our line. It's going to be y equals, that's what our h of x is, mx, which is going to be 2x, plus b, which is going to be our 7. So there's our equation of that line. There's that blue part right here. We found that line. Okay, and now let's go look at the other. Let's change colors on it so we can see it a little bit better. Let's make it red. So we're going to find that equation now. And that sure does look like a square root function. And it looks like it's been moved. Okay, so, and it's been reflected. And let's see, it looks like it's bounded between -3 and 1. So it looks like we're going to say from -3 to +1. And again, open and closed is because of the circles, or the greater than or equal to, and then less than. So let's see what we can do with that. This is a square root function. If it would have started from 0, I think we are reflected, so we have a negative sitting out there. And we have a square root. And looks like it's been moved over 1, 2, 3 places it got moved. And so that's going to be an x plus 3 since you went to the left. So, and then it looks like it got moved. Looks like we're moved up or down 1. Well, if that point's up there, then we moved up 1. So there's our equation for that one. And then it looks like we've got a parabola. So let's look at that one. Let's change our color again on that and see. For this one, looks like we are bounded between 1 and 5. And this one looks like it's been moved over 3 and up 5. So it's been x minus 3, that moved it right 3 and then up 5, and it's flipped over, so we got to put a negative out front. All right, that's all of our moving and our parent functions, writing those out. Now identify the domain. Well, it looks like as far right as we'll go is negative, or far left is -6, and we have a break at -3, and then we'll pick back up on the other side of that -3 and go to, looks like 1, but 1's filled in down there, so looks like we'll keep going until we get to 5. So there we go, and 5 is included. And then let's see about the range. Looks like we're going to start with -5 and stop with +5. So this is going to be -5 included to +5 included. Okay, moving on. All right, so let's see. If P of X is one thing, and then identify the values for which P of X equals H at X. So we're looking for, we can add that P of X up to our graph or down here. So P of X is going to be flipped over. It's moved to the left 1 and up 3. And so I'll look something of the sorts. Okay, and so, well, let me fix it on this side. It needs to go through that point. Okay, y'all use your imagination for my graphs. So identify the values for which these two equal each other. Now, in the explanation, when those two equal each other, that means that P of X and H of X are intersecting. At points, and then those points of which they intersect, well, look at where they're going through. It's at open circles. At open circles. Circles, so their intersection does not exist. Does not exist. All right, looking at the next one, it says identify values of X for which H at X equals 0. So where can I get a 0 value? So it looks like we're going to get 0 at -2 and -3.5. That's where it crosses the x-axis, remember. H at X equaling 0. Identify for which values is H of X greater than 0. That's where we are above the x-axis. So if we're above the x-axis, where does that occur at? Well, it's going to start but not include 3.5 over to -3, union, -3 to -2, union, and then 1 to 5 included. Right, and then identify the values for which x has h of x less than 0, so below the x-axis. So you're going to start way back over at -6 and go to 3.5, and then union -2 over to 1, and 1 is included. Okay, some more questions about it. Identify the values of x where h at x is less than or equal to 0. So we're going to include now -6 to -3.5, union, and now we're including -2 to 1. Now we want to talk about greater than or equal to 0, so see how that changes. We're going to include -3.5 to 3, -3, union, -3 to 2 to -2, and then union 1 to 5. Okay, so where are the values such that p of x is greater than h of x? That's going to be from -6 to -3, and then union -3 to 1. And that's supposed to be parentheses. Now it really doesn't look like it. Let's fix that. All right. Now what about that p of x is less than h of x? So we're going to go from 1 to 5 included. And then where is h of x increasing? That's going to be from -6 to -3, union 1 to 3. And then for what values of x is h of x decreasing? Well, -3 to 1, union 3 to 5. All right, you can continue on and get homework solutions, or stop the video from here and do your homework and then come back and check it. All right, this is day 5's homework. We are going to remind ourselves that f of x is the solid line and g of x is the dashed line. So for the first part, identify each of the following values of x, and this is going to go back through everything. So the first one, intervals where g of x is less than f of x. So then the graph of g of x, just to remind ourselves that the graph of g of x is below f of x. And then over what interval does that occur? That's going to be from -7 to -6, and then union 6 to 10. Okay, the next one, you're talking about where g of x is greater than f of x. So that's where g of x is above f of x graphically. And so for that, then that interval is going to be from -6 to 6. Okay, moving on. Here the values where f of x equal g of x. In other words, f of x and g of x intersect. That's what's going on with those two. And so over which interval does that happen? Well, no, that doesn't happen over an interval, silly me. That's going to happen at points, and those points it's going to happen at x equals -6, or it can happen at +6. Okay, and the next one, the values of x, so that g of x equals 0. So that tells me that g of x is on the x-axis. So if g of x is on the x-axis, that's going to occur when x is -7 or when x is 10. Okay, the next one's find the values of x such that the product of g of x and f of x is greater than 0. So in other words, f and g of x, they're on opposite sides. Opposite sides of the x-axis. That's what that is saying for us. And so that happens at -7 to -5, union -3 to 1, and finally from 4 to 10. And then where their product, oh, that's positive, not opposite, same. Y'all go back and fix that. I read it to say less than 0. It's on the same sides of the x-axis. Here's going to be different sides because the product is less than 0. So different sides of the x-axis. Different sides of the x-axis, and that's going to occur between -5 to -3 and 1 to 4. Okay, moving on. Now this next part, instead of doing 2 graphs, they did a graph and then they did a table. So looking at this, we're going to be picking out values. So for the first one, what is the value here? And we're just reading the table or we're reading the graph. And so filling in here, you're going to have 4 times. We're going to have -2 times 2 minus 2 times -5. And so that's going to give you 4 times -4 plus 10. And so you're going to get 24. Number 8, you're going to have a times 2 squared minus 3 times 2 equals negative 2 minus 4. So you're going to have an equation here. You've got 4a minus 6 equals negative 6. And so 4a equals 0, so a is going to be 0. Okay, and now looking at over the intervals in which f of x is increasing, so those intervals are going to be negative 5 to negative 2 union 1 to 2. And then the intervals in which f of x is decreasing, negative 2 to 1 union 2 to infinity. And then identify where we're constant, and then there are no intervals of which you're constant. So that would be none. Just making sure, yep, I don't see any. All right, hopefully all of this is sinking in.